In 1903, deep inside Gough's cave, in Cheddar Gorge, England, workers found a skeleton, 10,000 years old. They named him Cheddar Man. For over a century, no one truly knew what he looked like. Then in 2018, scientists finally read his DNA, and the result made no sense. Dark skin, blue eyes, living in Britain, in the last cold breath of the Ice Age. Everything you've been taught about ancient Europe, the pale skin, the fair hair, quietly falls apart in that one genome. A hunter, with skin as dark as equatorial Africa, thriving in a gray northern land, surrounded by ice, fog, and short winter days that offered almost no sun at all. How is that even possible? To answer it, we're not going to start in Britain. We're going back 2 million years, to Africa, to the exact moment your skin became a problem worth solving. Forget what you think skin color means. It was never really about race. It's about light. Every human being alive runs on the same two biological forces, pulling in opposite directions. Melanin, the pigment in your skin, absorbs ultraviolet radiation and converts it into harmless heat, shielding what's underneath. But that same sunlight, specifically UVB, is also the trigger your body needs to manufacture vitamin D. Block the sun, and you lose that. Let it in, and you risk damage. More protection means less vitamin D. Less protection means more damage. There's no version of human skin that wins both sides of that trade. Every shade alive today, from the darkest to the palest, is a compromise, a negotiation with the sun, written into your DNA. But that raises the real question. Why did humans need so much protection from sunlight in the first place? Go back further. Before dark skin, before the sun was even a threat, your ancestors were covered in fur, like every other primate on the savanna. Then something changed. Fossils like Turkana boy, found in Kenya, show a tall, lean body built for one thing, running long distances under a brutal equatorial sun. That kind of endurance needed serious cooling. Millions of sweat glands releasing water straight onto open skin. Fur trapped that moisture and blocked the cooling process entirely. So, sometime between roughly 3 million and 1.2 million years ago, researchers infer our ancestors gradually lost most of their body hair. It solved the heat problem, but it created a brand new one. Bare skin, under the strongest sunlight on Earth, was suddenly exposed, undefended, for the very first time in our history. So what replaced the protection that fur once gave us? In 2004, geneticist Alan Rogers examined the MC1R gene, the master switch for dark pigmentation, across African populations. He found something extraordinary. For 1.2 million years, that gene barely changed at all. Almost zero mutations survived. That's not an accident. That's nature refusing to let go. For decades, scientists assumed the reason was skin cancer. But it wasn't simply cancer. Cancer strikes late, long after most people have already had children, so it couldn't have driven pressure this strong. One leading explanation points somewhere else. Folate. Back in 1978, Branda and Eaton showed that strong sunlight destroys folate in human blood within about an hour. The same folate a growing embryo needs to develop a working spinal cord. Dark skin wasn't just protecting a person. Current evidence suggests it was protecting the next generation. But if dark skin was this valuable, why did some humans later become lighter? Somewhere around 60 to 50,000 years ago, humans began walking out of Africa, north, into landscapes the equatorial sun had never prepared them for. Scandinavia, Siberia, Britain, places where winter sunlight is weak, low in the sky, and starved of UVB for months at a time. The dark skin that once saved lives now became a liability. It kept blocking the very light their bodies desperately needed to make vitamin D. Without it, bones soften. Children can develop rickets. Women can suffer pelvic deformities that make childbirth dangerous, even fatal in the worst cases, especially far from any real medical help. In these low-light environments, the old advantage flipped completely. Heavy pigmentation, once essential for survival, was now quietly working against it. Natural selection began pulling in the opposite direction, favoring lighter skin wherever the sun simply wasn't strong enough anymore. So, how does evolution let the sunlight back in? The answer came from an unexpected place. Not a human skeleton, a fish tank. In 2005, researcher Rebecca Lamason was studying zebrafish with a striking golden stripe instead of their usual dark one. She traced it to a single gene, called SLC24A5, controlling how pigment is packaged inside skin cells. Then her team checked the human version of that same gene. It matched almost perfectly. That one variant, researchers found, accounts for a meaningful share of the skin tone difference between Europeans and West Africans. Not everything, but a real and measurable piece of it. No single gene explains all of human skin color, and no serious scientist claims it does. But this discovery cracked the door wide open. A humble aquarium fish had just handed scientists one of the biological keys to European skin. But was this the same genetic solution everywhere lighter skin evolved? Here's where the story gets stranger. East Asian populations also evolved light skin, adapting independently to their own low-sun environments far from Europe. You'd expect the same genetic fix. They didn't get it. In 2010, researcher Melissa Edwards and her team found that East Asian light skin comes largely from a different gene, OCA2, not the SLC24A5 variant that shaped European skin. Different populations, different genetic pathways, similar result. Nature answering the same question twice, without copying its own homework. This is convergent evolution, happening in real time. Two separate human groups, on opposite sides of the planet, independently solving the exact same problem. Not through shared ancestry, but through the same relentless pressure from the sun. Light skin wasn't inherited once, from one shared ancestor. It was invented twice, by two populations, using two entirely different sets of genetic tools. So what changed the speed of this transformation in Europe? This is where Cheddar Man comes back in. In 2014, researchers sequencing La Brana 1, a 7,000-year-old hunter-gatherer from Spain, found he still carried the ancestral dark-skin genes. Cheddar Man, at 10,000 years old, carried them too. Modern light European skin isn't ancient at all. It's surprisingly recent. So what changed it? In 2015, Ian Mathieson tracked the shift across ancient genomes and found it accelerated sharply between 8 and 4,000 years ago, right as farming spread across Europe. Farming didn't create the pressure toward lighter skin. The low northern sun had already done that. But a grain-based diet, stripped of the vitamin D found in fish and meat, may have intensified a selection already underway. And Cheddar Man himself? A hunter, eating fish, pulling vitamin D straight from his food. His skin simply never needed to change. But was this story unique to modern humans? Even our closest extinct relatives face this same pressure. In 2007, Carl's Lalueza-Fox sequenced DNA from Neanderthal remains and found a unique mutation in their MC1R gene, one never seen in modern humans. It likely produced pale skin and red hair in at least some Neanderthal populations, though certainly not all of them across every region. A different species, evolving toward a strikingly similar answer, entirely on its own, with no help from us. And that's the real reframe here. Skin color was never evidence of separate human origins, different species, or different worth. It's adaptation, playing out again and again, within a single species. Sunlight, geography, migration, diet, genetics. 5 forces, endlessly recombining, writing themselves onto human bodies on every continent on Earth. Which brings us to the skin you're wearing right now. What story is it quietly telling about where your ancestors walked? Think about what you just learned. 2 million years of sun, migration, hunger, and survival, compressed into the exact shade of skin you were born with. It isn't decoration. It isn't a boundary between people. It's a record, a quiet inheritance from ancestors who walked into deserts, forests, ice, and coastlines and adapted, generation after generation, just to keep their children alive. Cheddar Man carried that record in dark skin, 10,000 years ago, in a cold gray Britain that never once asked him to change. You carry your own version of it, right now, whether you've ever thought about it or not. Not race, not hierarchy, just geography, written patiently onto the body, over an unimaginable span of time. Before today, what did you think made us different colors? Tell me in the comments. I read every one. And if stories like this move you, stay close.